So one of the questions that we will seek some answers for this week is psychology a science? The forum topic that's been assigned asks your opinion, but I think it's necessary to temper that opinion with some information about how psychology goes about doing its research. So that's what we're going to talk about right now. So in general, it's necessary to ask the question, what does science require? So science, regardless of what area of science that we discuss, whether it's physics or chemistry or biology, or in this case, psychology or some of the social sciences, it requires the systematic study through observation or experimentation. That it is systematic rather. So there is a process and a procedure for science. Now in psychology, there are basically 4 main goals, and they're tiered in that each one is kind of more specific than what preceded it. So in general, we can do research that just seeks to define what's happening. It's basic descriptive research. We've noticed this thing going on, and we're just describing what we know of it. The next tier is explanation. So if we can identify what is happening, we may seek to understand why it's happening. The third tier is prediction. So I think, if you just think in general about research, a lot of research has the goal of prediction. So if we can define what's happening, we understand why it's happening, then the next piece of that is, can we predict when it will happen again? And finally, the ultimate goal for psychology is control. So if we can define what's happening, we know why it's happening, we can predict when it happens again, then it makes sense that our next step would be to perhaps control. Can we control this behavior? Can we prevent it from happening? Can we change or modify the behavior? So in a basic sense, we see these things and research that's released, but we don't necessarily think about it. So if you're looking at the corrections system, for example, the goal of the correction system is to prevent that behavior from reoccurring, or to keep the general populace safe. Those goals do not exclude each other necessarily. So what we will find, though, is that control of the behavior is perhaps the most difficult. And so in psychology, when we look at the study of behavior, we actually go pretty in depth, and we'll talk about it quite a bit when we get to chapter 6, which is the learning chapter. But we find that control of behavior, even in the field of psychology, is very difficult to obtain. That we can set things up to where we influence behavior, but to be perfectly honest, the study of people is kind of messy. So when we discuss different types of research, now that we've talked about the goals of research, there are basically 2 general categories of research, and this applies across the sciences. You have basic research, which the aim of basic research is to gain general knowledge. You just want to know more about a thing. You're not necessarily trying to prevent anything. You're not necessarily trying to treat anything. We're just trying to find out more about it. So one of the areas that's been under a lot of research recently is concussion research, specifically CTE. And if you haven't heard of that, it'd be worth a Google search on your own, but that's kind of outside the scope of this class as an entry-level psychology class, but wanting to understand the cumulative effect of concussions. We're not necessarily applying that knowledge, but part of getting buy-in for we need to do something different is to understand the damage that may be occurring as the result of participation, in particular in certain athletic sports. So that would be basic research, where your ultimate goal is to gain general knowledge. Applied research focuses on solving problems, and the problems that we're solving can vary quite a bit. We can be discussing early interventions for low-income preschoolers, or we can be talking about research for a drug trial for a new medication for schizophrenia or for ADHD. So again, we require both types of research. So one is not superior to the other, but it is useful to have both in combination because we get a broader picture of what's going on. So without basic research, we really can't design applied studies, but ultimately the goal of most researchers is to contribute to their field in a way that then will go on to solve problems. So you guys may remember from way back when the scientific method. So we still are bound by that, even in research in the social sciences. So the purpose of the scientific method is kind of twofold. Number one, it helps us to reduce bias and error in research. The second one, this is a means of accomplishing the four goals of psychology. So that description, explanation, prediction, and control. So if we're all using the scientific method, we don't necessarily pick the exact same experimental methods to study. We basically are all using the same very general procedure. So if you remember the 5 steps of the scientific method, we won't go into them in detail, but you are responsible for knowing them. So observation, which is perceiving the question. When we talk about it in a social science field, often observation is not even just the researcher's individual observations, but doing a literature review of the existing research, because research funding is such that we want to make sure that we are actually studying something that is meaningful to study, or perhaps designing our study so that we're filling a gap in the current knowledge base. So you need to form your hypothesis, you need to test your hypothesis, you need to draw your conclusions, and you also need to report. So later on in this lecture, in this PowerPoint, you will have the opportunity to click on a link to and it's basically an HBO show last week tonight that's discussing some of the issues with scientific reporting. It's a very interesting conversation, but basically the take-home message on that video is that things don't always get reported, or sometimes when media gets a hold of the report, it can get a little twisted out of shape. But reporting is absolutely essential to research so that other researchers understand what's happening in the field, and it also is a way for us as lay people to access some information. Okay, so again, I'm going to skip through these slides for the purpose of this video. So we're going to go to drawing conclusions. So one of the things, if you are reading research for your final project that you'll turn in much later in the semester, one of the things that you'll see is in actual scientific write-ups, there's a conclusions part of it. So they give you all the procedure that they use, they give you how they set aside their sample groups, they give you all of that, they give you a bunch of raw data, and then they walk you through the conclusions. So a couple of things about drawing conclusions. Your raw data needs to be converted into meaningful data. That can oftentimes be done with the assistance of graphs. You also need to use statistics to determine whether or not your results are significant. So that's not just something that researchers do. There's actually a whole field of math dedicated to determining the significance of data collected during experimentation. We are not an upper level research class, so I'm not going to walk you through those procedures, but I do want to let you know that there are procedures there. So if you ever see anything in mainstream media that reports the results as nearly significance or approaching significance, that's not a thing. They were either statistically significant or not. So if they can't describe the statistic significance of their data, it's not. So that is one way sometimes that data can get misconstrued in popular media. The other thing to let you know, one of the things that is important about graphing is it takes your data and it makes it visual. Most of us, to some extent, have some component of our learning that is preferred to be visual. And so you take a bunch of raw data points like you would see in this graph and you make it visual so you can see how it clusters. One thing that you have to be aware of in analyzing data is that this is actually a linear regression line. So this is saying if we kind of took the average, made a best fit line, this is the line. And we can create an equation for this line, which allows us to make predictions for some of the data that occurs in between the dots. But it would be inappropriate for us to assume that this line continues in a linear fashion after the end of our data points. If we want to know what's happening out here, we need to collect more data. So when you're reading research, look and check, are they making predictions beyond what they've collected data for? Are they assuming a linear relationship when we don't have any data that supports that that relationship continues to be linear? Okay, reporting results, again, a pitch for using graphs. The big thing or the big issue or importance of reporting results is that when you report your results, one of the other procedures that happens in science is replication studies. Replication studies are very important. It's possible sometimes to complete a study and get some results that are atypical that we might attribute a lot of significance to, but when we do replication studies, we don't have the same results. So having a body of researchers completing similar research or repeating the same research adds to the mound of evidence that's supporting what you're testing. You'd never want to make your decision based on one study alone. So again, why would you tell somebody if your experiment failed? Because there is a reporting bias in the scientific community where we want to report successful research because that's how I get funded again as a researcher. But reporting or owning experiments that don't go quite the way you want it to is very important. It allows other people to try different methods. It also helps ensure that people aren't continuing to throw research money at something that has been shown to be invalidated, or it turns out that it's difficult to study. We don't want to waste research money because there is a finite resource there. It allows for the critical review of other scientists. So sometimes you might have been kind of blind to something going on in your study, and it creates data that then you can't interpret or it's not significant, but somebody can read over the research you've done and said, hey, did you consider this other variable? Maybe that's what impacted your study. So sometimes you can get feedback from your peers in the scientific community that can then put you on a path that may be more productive for what it is you're trying to study. And all research provides some type of evidence. So basically, you create a hypothesis and you're trying to determine whether or not your hypothesis is supported. Even a hypothesis that is not supported, that data that you collect is evidence. So again, it's very important to report all research, but frequently only successful studies are published. Okay, so ethics. So this is a very important conversation that I'm just going to highlight for the purpose of this recording. There's some additional information in your textbook. I'm hoping to upload some additional ethics information as well. It is important to understand that we cannot study just whatever we want. In the field of psychology. There's going to be a number of experiments that we talk about throughout the course of the semester that we really could not do the same way today as we did it in the 50s or the 60s or the 70s. Because as we have continued in the field of psychology and done research, we've decided that we need to kind of set out some specific guidelines. So an example of a research study that would be unethical is that if I took our cyber community here and I wanted to study the effects of nicotine on a developing fetus, and I said, all right, everybody of childbearing age, I'm going to split you into two groups, and one of you is going to smoke a pack a day every day until you give birth, and the other group is going to be the control group, and they're not going to do that. Hopefully, even having that study suggested causes you to bristle and go, my goodness, you're a terrible person. Not that I want you guys to judge me, but hopefully that kind of creates a blip on your radar where you go, no, you can't do that. We are pretty sure, we're real sure, no, we're definitely sure that that would harm somebody, right? So there are safeguards in place for research. So you can explore that topic a little bit further in your book, and I would encourage you to do so because that is usually an exam question. Okay. So there are some important common methods to research that I want you to be aware of as well. And it is very important for the test, very important that you know the difference. So descriptive methods are ways to collect data. They're not necessarily experiments. As a matter of fact, they are not experiments, but they are other data collection techniques. They are valid and they are useful, but they are not the same as an experiment. So naturalistic observation is when you are in the environment for the thing that you are wanting to study. So an example that I commonly use is, say you want to study caregiver-child interactions. Then you could do that in a daycare. by just going and job shadowing at a daycare and just looking and, sit in the corner with your clipboard and kind of write stuff down. You could go to a park and watch as caregivers bring their children to the park and record information that way. One of the limitations of natural observation as a descriptive method is that it's not always possible. And think about being the creepy person sitting in a public park with a clipboard. You might get some angry parents in your face wondering what in the world you're up to, but you also don't have very much control. You know nothing about the subjects you're studying. They come to the park, they play with their kids, you chart the interactions, and then they leave, and you've got no idea what happened before or what the relationship with the caregiver is. And so you can see some patterns or some things, but you've got to kind of question, okay, what can I do with this information, because I know so little beyond just what I have observed. So to gain additional environmental control, it's possible that you can do laboratory information. So again, if I want to study caregiver-child relationships, I can send out and recruit families to come to my laboratory to participate in this, so I can collect basic information so that I know things like the age of the child and the relationship of the caregiver with the child. And I can just put them in my lab that's set up with the toys that are age appropriate to the child and watch how they interact. And I can sit on, behind a two-way mirror and record my observations, and that's great. However, laboratory observation, for all of its positives, is often criticized as being artificial. So observation is a tricky thing because you've got the worry that if somebody knows they're being observed, that they might behave differently. That's called the observer effect. But you also have potential observer bias, where I might define something as a positive in a relationship between a caregiver and a child, whereas somebody else, if they have the same clipboard and we're watching, they might define that as a negative interaction. So it becomes very important when you're doing these kinds of research, particularly with observation, that you have clear operational definitions, which means that what is considered a positive interaction is clearly enough defined that I could give any one of 15 people my clipboard and they would come up with basically the same data. Moving on to case studies. So case studies are super interesting and they're honestly quite common. So, if you're watching The Making of a Murderer on Netflix, where it's a documentary that goes really into depth on a single person, that's basically a lay example of a case study. In psychology, one of the first case studies that we mention is Phineas Gage. And we mention his case in relationship to getting basic information on how the brain works. So we collected a lot of data on this person that had a traumatic brain injury. In the 1800s, he had a spike shot through his skull, a railroad spike. It was an accident, on the job accident. But so we learned a lot about what damage to certain areas of the brain can cause and the shifts that it can cause in personality or behavior or ability. But we have to think with case studies, so is that data generalizable? Will that apply to every single person with this injury? Or was there something unique about this person's particular background or initial ability? So case studies are helpful, but depending on the topic, quite often we question the generalizability. Can we apply this to everyone? So for those of you that really like watching serial killer documentaries, and you go, oh, well, this person had a bad childhood, or this person had this factor or that factor. A lot of times what we understand with psychological research is that there may be risk factors, but risk factors alone are not necessarily predictive of outcomes. So we have to be very careful when we go to apply information from a case study to a general population. Another type of descriptive research is surveys. So surveys are great. You can send out a survey through email. You guys as students here will probably get a survey toward the end of your time here or around May, just to get your opinions about how things that are offered on campus and that kind of thing. But one of the problems with surveys is that they often have a low return rate. So if you think about it, you may, if you've been here for more than a semester, have received a survey from LCC. Did you stop and fill it out? right? It's really easy to click delete and move on. So surveys tend to have a very low return rate. A return rate of about 30% on a survey is actually doing pretty good. The other thing that we see with surveys is the people that respond to the survey itself and the topic of the survey tend to be those that feel most strongly about it. So you essentially might fall into the category of you're collecting extremes of information through your survey. And you think, okay, with those limitations, why would we use them? Well, frankly, surveys are cheap in the digital age. You're not, paying somebody to stuff envelopes to send this stuff out. The other thing is there are just certain things that people would be more likely to report in an anonymous survey than they would be face-to-face. So again, thinking of our digital classroom, if I individually emailed each one of you and you had to respond to a list of questions directly to my email and I would know who you were when you responded, are you likely to give me specific information about drug use or sexuality questions or certain things like that? Probably not. But if you were sent a link to a survey that collated the data somewhere else and then just gave me answers to the questions, but no actual information to attribute the data to yourself, then you may answer questions more honestly about illicit drug use and that kind of thing. So surveys can be a good initial place to start for researchers, again, depending on the sensitive nature of the topics they're trying to study. So experimental methods then, we just finished talking about descriptive research. Experimental methods are when we're actually using the scientific method and setting up an experiment. And there is an awful lot that goes into that. Even some of the older studies where we question the ethics of what was done, there was a lot of prep work that went into that. Experimental research is the only way that we can determine cause. With other types of research, we can maybe identify a correlation, but until we directly study it in an experimental setting, we are not able as researchers to say A caused B. So for those of you guys that have already taken a science class, hopefully you are familiar with the independent variable, dependent variable, and you may or may not have discussed extraneous variables. So for those of you guys that don't remember the difference between independent and dependent variables, take a minute, pause the video and go and look it up. But I do want to spend a minute on extraneous variables because that's probably for most of you a new idea. So an extraneous variable as it applies to social science research is when you have when you are seeking to study a particular thing, but something outside of what you intended to study is going on. So if I'm looking at ways to improve concentration, but it doesn't seem like anything that I'm doing is working, then, maybe there are other factors impacting concentration. So maybe the students aren't able to concentrate because they haven't had a meal, or maybe they're sleep deprived or other things. So that I might be studying interventions to improve concentration, but I might be in a situation where we've got diminished concentration even off of a student's normal regular day. And if you consider and you think, oh, well, that would be obvious. I once taught a night math class and it was mostly athletes, and I'm not saying that in a derogatory way, but what I noticed is I had student athletes that had 2-a-day practice, or they had their practice at 6:30 in the morning, so that by the time we rolled around to when the class started at 6 o'clock in the evening, they've been in class all day, they've been to one or more practices. And what I found out is the dining hall was not letting the students in my class leave with their food. And by the time they got out of practice and were trying to come to my class, they were just skipping meals to be there. And so I had so much trouble with students not paying attention or falling asleep or interrupting or just talking to the person next to them. And when I finally figured out what was going on, because the student came up to me after class one day, I just pushed the class back a half an hour, and night and day difference. And so again, was that an experiment I did? No, but I just want to make the point about extraneous variables. So there are two groups minimum in an experiment. You have the control group and the experimental group. Now the experimental group can have other subgroups. So if you're trying to determine dosages for medication, you may have 2 or 3 different dosages you're trying out, but then you also have the control group that does not get the medication. So experiments require random assignment and thought given to the control of extraneous variables. So random assignment doesn't mean like you open up a phone book and you pick names at random, but for the people that meet the qualifications of the study, they are randomly assigned to either the control group or the experimental group. Now, there's a couple of effects that you need to be aware of. So there can be a placebo effect. If somebody believes that they have received the treatment, they may report more favorable outcomes for whatever it is you're trying to study. And if you think about it, if you're doing a pharmacological trial and your control group gets nothing, like not even a sugar pill or something like that, it's going to be really obvious to them that they are not in the experimental group. So there are things you can do as a researcher to minimize the impact of that. You can have the experimenter effect. So this one is kind of nuanced, but if you as the researcher know what group somebody is in when you are collecting the data, you may alter the questions in such a way to get feedback. So if you know that somebody has received the experimental treatment and you're collecting data about how they are feeling afterwards, you might very innocently say, are you sure that you haven't noticed any improvements in blank, right? So you're trying to make sure that you're getting accurate data, but in fact, you are biasing it because you would not be asking that question if you knew that they were in the control group. And so as experimenters, we have to be very careful. So often we have single blind and double blind studies. So a single blind study is when the person that is participating in the experiment does not know what group they're in. So that's, minimum standard there. A double blind means that the participant and the person collecting the information don't know what group that person is in. And there's ways to set that up and control for that. But that is a pretty good standard to hit. That way, as we collect our information, we're not accidentally biasing the data that we're collecting. So I'm going to hopefully finish up this recording in 5 minutes or so. Again, I encourage you to go back to your book to collect additional information. I also would like feedback on this recording to see if this is helpful. So anyway, but continuing with sampling. So your sampling must be representative of the population you're trying to study. So one of the things that psychology struggles with is we use a lot of convenient sampling. So if you look at a lot of research that exists, particularly in the field of education, in larger universities, it's quite common for students that are taking general psychology to have an experimental participation requirement as part of their gen psych class. So you sign up for a study at some point and participate in a study, and then you get your completion points for that. Well, so that means that a lot of educational research is done, on first-time freshmen at such and such Midwestern University, right? So if I am trying to gather experimental information on something, then sampling a bunch of freshmen only really applies to other, freshmen or maybe college students, depending on the sample dynamic that we took from. So if I'm collecting data about high school students, I can't just walk into the high school and hand out a bunch of surveys, get all that data and go, this applies to all adults, right? Because all I've done is collected data from high school students. So you've got to be representative of the population. So if you were trying to make a claim about something across adults or across young adults, then you need more than just, 2 years worth of data. So you wouldn't just sample 18 or 19-year-olds. If you want to apply something to adults, you would sample people, through their 40s maybe. And then when you released your data and published your results, you would describe your sample so that people would understand how they could apply that data that you generated. Your samples must be random. So they have to meet basic criteria. You couldn't do a study about contraceptives for women if all of your participants were not women, right? Or women of childbearing age. But even once you narrow your candidate pool, then your assignment to the experimental group or the control group should be random. And your samples must be of reasonable size. So if I'm studying socioeconomic variables for Southeast Kansas, in 2000, that census data, there were 180,000 of us that lived in Southeast Kansas. Do I have to, for good experimental research, get data from all 180,000? No, and that would be very difficult to do. You just couldn't ever do research if your sample had to encompass the entire population. But statistics tells us the minimum number of data points we have to collect or participants we have to have for the study to be of reasonable size so that we can collect the data in a meaningful way and apply that data. And the number is oftentimes smaller than what you think. Okay, sorry about that interruption. So your samples must be of reasonable size. The sample size that's required is normally not quite as large as you think, but if we're trying to apply something to the entirety of the United States, we clearly need to probably sample more than 30 people. And again, we would need our sample to be reflective of the diversity of whatever we're trying to report on. So. The other brief mention that I want to do really quick is on correlation. So I had a grad school professor jump up and down and yell, correlation does not equal causation. Those are different things. However, every causal relationship has at least one correlation. So it's really important to pay attention, specifically when you're looking at studies that have been released in the media. Is this a correlation or a causation? So there's degrees of correlation, which you can look at the chart here. And there are types of correlations, and particularly the most common ones that we will look at this level of psychology is a positive correlation and a negative correlation. So those are not value statements. It doesn't mean good and bad. It just indicates the direction of the relationship. So in a positive correlation, as one variable goes up, the other variable goes up. So as the time you spend studying goes up, your exam grade goes up, right? So those would be said to be positively correlated. So a negative correlation, as one thing goes down, as one thing increases, the other decreases. Okay, so for instance, the less sleep you get, whoops, sorry guys, I got distracted by the pop-up alert and lost my train of thought. So let me try this again. So the amount of time spent playing video games may decrease your ability to perform on the exam. Okay, that would be an example of one variable going up, the amount of time playing video games, and the other one going down, which is exam score. Okay, so a quick talk on ethics, and then we will go ahead and I will stop this recording. Again, I encourage you to visit your reading list so that you can get additional information for the other topics that are covered in this chapter that you need to be aware of. But this recording is not meant to substitute for outside study, but again, is to give you kind of the broader thoughts and discussion on some of these topics that appear in your book. So there are a number of possible ethical concerns that can occur when you conduct research with people and animals. And so you can look at the APA, you can look online, you can look in your textbook. But what I've done is I've basically put together the 6 most common concerns that we talk about at this level of psychology. So institutional review boards. So I mentioned that research at the university level often uses students, right? So if I'm doing a research project with college students and I work for a major university, then before I can do that, before I can recruit you guys to participate, I have to have my institution's review board review what it is I'm trying to study, the procedures that I'm using, and to basically sign off and give me permission to do that. So there are some things that review boards look at. Now, again, if this was private research, hopefully that there would be some safety mechanism and check as well. So the first and most important thing perhaps is to judge the safety of the participants. We don't want to put any of our participants in unnecessary risk. And we will discuss that as we talk about some early social science experiments later on when we talk about social psychology. We also have to be able to collect informed consent. We have a duty to disclose to the study participants what it was we were actually studying. Now, we talked about observer effect and things earlier in this presentation. So if I wanted to study the nature of relationships between caregivers and children, I might use a little bit of deception, a little bit of this number 3, because if I want, you know, more honest responses, I might say something like, I am evaluating the kids' responses to caregiver direction, when really I'm looking at how the caregiver is giving the redirection, right? But at some point, I then have to debrief and say, okay, this is what I told you it was about. This is what it actually is about. It is possible to get informed consent and use deception for your study, but then you have to debrief afterwards. That is a nuance that trips students up every time on test day in this class. You can get informed consent and still use deception, but that there are extra safeguards like debriefing that have to occur before you can use and report on that data. In general, though, informed consent gives the participant some idea of what they can expect and what potential dangers, if any, there may be to participation and that kind of thing. Now, it's pretty impossible to draft a perfect informed consent that that takes into account every single thing that could possibly happen. But that does not mean that we did not get informed consent, if that makes sense. So there's a lot of nuance there. The role of deception must be warranted. So you cannot create a study and lie to people about what it's about just to do it. You have to be able to justify that you can't get that data any other way. Also, you have to be able to guarantee the confidentiality of participants. And even when we do case studies, we often use fake names or generate case numbers instead of using people's actual names. So confidentiality is absolutely a requirement and an expectation as well for the program participants. And then researchers must own the responsibility for the consequences of the study. So there are very important things that we can study in the social sciences, but how we study them could potentially cause trauma for the study participants. We need to have safeguards against that. But if we realize that there is some trauma going on, then we have a responsibility for that as researchers to stop participation for that person in the study and connect them into supportive resources. Now, you may think that we should be able to predict and prevent trauma from occurring, but sometimes we touch on subjects that re-traumatize a person without us realizing a person's full history. So for example, if we are doing a study or collecting data about domestic violence, having somebody talk to a researcher about that and give case history on that, they may think that they are okay disclosing and talking about that, but through the process of the interview, they may become agitated. It might be clear to the researcher that they, in fact, are not able to talk about it. So again, as researchers, we own some responsibility for that. So this is the video that I mentioned before. I encourage you to watch the video. Again, I put the warning on there kind of flippantly, but it is serious. There is some coarse language in the video, but the intent and the discussion that John Oliver has is actually quite good. And so I encourage you to watch through that. You can skip the fake commercial they do at the end. That's just complete satire. But I want to leave you with this thought if you watch that video, because it really highlights some of the downfalls to how research is reported. I show you this not so that you automatically just disregard any scientific evidence that anybody ever presents, but I show you this because I want you to be skeptical when you see something in the media. I want you to go back and check the original data. I want you to be able to think critically about this and to know, because I don't want somebody in the media getting a hold of research and manipulating your viewpoint by misrepresenting a study or data. And that's very common, as you'll see if you check out the link. So if you've got any questions or problems with the class, please contact me. Also, again, I encourage you to email me feedback. I know that this is not a perfect system for having a lecture replacement, but I want to know if it's valuable, because this does take some time, and I want to make sure that we're spending our time with resources that are helpful to you. So please give me some feedback through email on that.